All right. Welcome to my little presentation on new glance on old machines. I'm really happy that you're still with me, although the show is really over. So I would like to start and show you something. You may know some of these people here. This is actually, of course, Mr. Obama and Mrs. Merkel. And this was last year at the Hanover show where we won the Hermes Award. So it's a little bit like the Oscars of the industries. And here's our CEO. That's why I actually have the slide here. So Mr. Harting, that's the son. Then we have here our senior. It's Dietmar Harting, right besides Mrs. Merkel. And at the moment, this is the daughter. She's in the company responsible for taxes and money. And this is a very important person here in yellow. This is Mrs. Harting, senior. And she is responsible for CI and all our cultural engagement. I'm not sure if you have ever heard of Harting. Actually, we're a company in the region of close to 600 million euros turnover. And actually, we sell a very, very old, let's say, boring product. We are producing connectors, heavy-duty connectors for big machines. And that's actually our core business. And now you may ask, what a company like Harting is doing at an IoT event? And that's actually a very good question. Let's see a little bit. So this is our core product. It's what we call HAN. And HAN stands for Harting Norm. So Harting is really setting the standard for connectivity on machines. So if you have the chance to go to the plastic show, which is in one of the other halls, and if you look at these big injection molding machines, we are very happy that almost all injection molding machines are using Harting connectors. So that's actually our core business. We are experts in producing high quality, high reliability connectivity between different things, between machines. And here, just to give you an idea, this is for high power, something like 200 amps. This one again, here you have pressured air, here you have standard Ethernet and some signals. So that's actually our core business. And as I showed you the Harting family, Mr. Harting told me, okay, we need to do something to ensure our business. And what is the next level of connectivity that we have to take care of? And the idea was that we take this idea of connecting machines with power, signal, and data to connecting machines with information. So getting information out of machines is one of the key topics for the Internet of Things. If you really think about, have you any feeling about how many machines are out there? The first estimates that we have seen is that there are about 100 million legacy machines. So old machines at some producing companies like Harting. So Harting is really a manufacturing company. Just to give you a feeling, Harting has about 100 injection molding machines. So really plastic making machines on our shop floor. And of course, they are connected with these here, but really the Internet of Things idea is that you take those old machines and connect it to databases or even to the cloud. Of course, we have seen here a lot of companies at the IoT conference, from Google, Microsoft, Rockwell, all the big ones. So of course, all the clouds are there and available. But the key topic is, how can I connect these old machines? Because nobody will throw away an old machine just because the connectivity is missing. The typical lifetime of a machine that Harting is using and all the other ones is about 20 to 30 years. And when you think back 30 years, there was no iPhone, there was almost no internet. So nobody was thinking about having the capability of connecting old machines to whatever we have today. And that's why we said, okay, let's think about what is the capability of Harting to contribute to the Internet of Things. Okay, some more here. We, of course, have switches. That's one of the next steps we took about 10 years ago, where we said, okay, this Ethernet is coming up. The machines are getting connected with Ethernet. Nevertheless, it may be Profinet, could be Ethernet IP, could be EtherCAT. So you have to take care of the Ethernet communication. And on the other side, Harting provides all these things here to have complete infrastructure at the shop floor. So we are a one-stop shop. If you say, okay, I have my machines, I want them connected, I need switches, I need connectors, then you're right with Harting. Okay, but now let's build the bridge why Harting is at the IoT conference here, which I really appreciate. And this is quality, to be honest. That's our reason to be here, why we say, okay, you find things like a Raspberry Pi or a BeagleBone Black, which of course are excellent devices for connecting old machines, but they are not industrial grade. And I can tell you some stories from big automotive companies in the southern part of Germany where the engineers took, because it was quick and easy, a Raspberry Pi and built the Raspberry Pi into the automotive production. And they had to stop the production because the engineers found out that there was no legitimacy, so that it was not allowed to produce or to use a Raspberry Pi in the production there. And that's why we are here as Harting. We stand for quality. Our products are really having a lifetime of 10 to 20 years. If you need spare parts for connectors from the last 30 or 40 years, this is really no problem. So quality is really the aspect why we are here, and we want to bring this industrial grade of quality down to the machine and connect machines for the next 10 to 20 years. Okay, here we are again with our connector. And the next step of connecting is connecting information. And how can we do this? And this is one of the answers that we found out, is that we are missing devices that allow us to connect to old existing legacy machines. Again, there are numerous protocols. There are myriads and thousands of different protocols and sensor types. And what is really missing is some capability of taking those standard sensors, connecting it to a black box, and then from there on, you can communicate whatever IT companies are speaking today. So you need something like MQTT, you need something like OPC UA, you need all these modern protocols there. And so what we build is a connector that connects machines and sensors to the new IT world or the IoT world. So really taking the protocols to the new standards like OPC UA or MQTT. What is very important here, and that's why you see it's built up a little bit like a puzzle. Normally, the typical number of machines, and Harting is a good standard here, is something like 50 to maybe 100 machines of the same type. That's quite a big number. And you need to have solutions where you can connect 20 machines, 50 machines, or maybe 100 machines. No company in the world, except for very few like Procter & Gamble or other big automotive companies, have seldomly more than 100 machines of the same type. So you need to be very flexible, you need to be adaptable. And that's why we designed a little bit like Lego for adults, so you can really put it together from different modules. And just to give you an example, you could, for example, choose over here RFID to identify objects, to identify tools, to identify metal boxes. And then on the other side, you could choose, for example, standard Ethernet, one option. Another option could be that you say, okay, I want to measure energy. Energy is very interesting. You can do a lot of condition monitoring based on energy. A motor, an electrical motor that gets older and older, and before he breaks, his current consumption changes. So by monitoring energy, you can learn a lot about motors, for example. So you take the energy here, and then on the other side, you may say, okay, I don't have Ethernet available, but I do have Wi-Fi in my plant, or maybe it's an off-site or off-location site. Then you say, okay, I need LTE, I need 4G. Then you could build with this toolbox a device that collects energy data on one side and has LTE communication on the other side. And the interesting part is that nothing in the software changes. Because of the software concept, you can just put together different hardware modules and say, okay, this is what I need on the communication side towards the sensor, and that's what I need on the communication side towards IT. And as I mentioned, we are really flexible here and say, okay, it can be wired or wireless. So that is actually the basic idea, taking this idea from Harting connectors, very modular, very easy to adapt, to a new information connector. And what we are trying to show and what we are trying to do with all our customers and partners is really show that it is easy to take these old machines and connect these old machines to the IT. This is a little bit how we see the world, and it actually transformed to almost all projects that I have seen so far. It's always about sensors. And Harting is not a sensor company. We're not producing any sensors. But we take those standard industrial sensors from all the big manufacturers. Could be Andres and Hauser for process industry. Could be colleagues from SICK or Peppel and Fuchs or Balov that really make high quality, excellent sensors. But the interesting part is that these sensors are not really very communicative. they don't like to communicate a lot. Of course, you can attach them to a PLC or to an I/O block, but then you're still in an automation world. You're still not in the world where you can easily program with Node-RED or where you use Java or Python or any kind of modern programming languages. So the sensors are somehow stuck down here. Let's jump to the other end. On top here, we're talking a lot about here, and what you see from Google and or Amazon is about big data and big data analytics. Of course, those people really want to have a lot of data, but the issue is, how do I get my data there? How do I really generate data? It's pretty easy to analyze, for example, Twitter messages. To find out what is going on Twitter is fairly easy. You just connect and find the data. Here in industry and manufacturing, you always have the issue, how do I get the data up here? Because the sensor, of course, has the data, but how do I connect the sensor in a way that allows us easily to get to the sensor data and to analyze it? And that's, in the beginning, we were a little bit surprised because, as I mentioned, Harting is the world leader for industrial connectivity on the connector level. But Amazon was knocking at our doors, Microsoft was coming, IBM was coming, and said, okay, what you have done there is pretty interesting, let's talk. And I was really surprised why they did this, because from a IT point of view, Harting is really a small company and only a niche offer for very special solutions. But what we understood is that up here you want to have a lot of data, you want to have information, but you need to get it from down here. So what is missing in many, many cases is something in between, what we call processing. And this is also what you find, for example, at different vendors. It's at the moment called edge gateways. It's really not a PLC, it's really not about hard real-time automation, but it's about devices that build a bridge between industrial space, industrial automation and communication, and IT. And that's here where we position ourselves as building the bridge between old machines, sensors, of course new sensors as well, pre-process the data and bring it up here. You have any idea how many data, for example, a KGaA robot is producing per second? It's about 4 gigabytes per second. So of course you could take this data and try to bring it up here. So we tried this with one robot. It is okay if you have really a high performance network, but the issue is if you have more than one robot, the IT or your internal IT in your company will become really, really mad at you because you break their network. If you would tell a robot, send all the data you have up to the cloud, you will really break every network that's in between because you are generating so much data that's almost unbelievable. So between just making a connection, it is really, really important here to have some cleverness, okay? Some, let's call it intelligence. Although I believe that only people can be intelligent and not machines, but you need something in between that makes the data into information, that really makes it valuable. Because nobody wants to know that this room, for example, is something like 24 degrees C, that nobody cares, but if it's getting warmer, this is irrelevant information, because then I can turn up the cooling. So what is happening in between here is that you need somehow a logic that decides, is this information really relevant? Is this information important? Or should I just throw it away? Again, taking our KGaA robot with the 4 gigabytes of data per second, of course this data is somehow interesting, but it is most cases not relevant. If the torque, so for example, if the robot changes and the motion gets more hard, more difficult to move, then there may be something wrong. This is irrelevant information. There could be something wrong with this joint here. And this is the art of logic that we want to be able to people have to bring onto an edge device. We don't say that Harting has this knowledge. We actually don't. But a lot of partners, a lot of customers know their machines very, very well. I have a picture in mind. We have these old machines in our manufacturing where there are people that hear, smell, or feel how the machine is doing. And what you need is some kind of software that is in between here that does this hearing, this smelling, this feeling, and says, okay, this information is relevant. And that's, I will explain that later on a little bit, that's why we are so keen on collaboration with partners and people that understand what is the machine actually doing, how is the machine feeling, what is the machine health, and what is the actual information that is relevant. Okay, so this is a little bit our picture, sensor data down here, big data up here, and what we are trying to close is really this communication gap. There is a gap between shop floor and IT, and the other thing is that we want to enable people to have their intelligence, their smelling, hearing, feeling somewhat put into software and offer them a platform that they can have it directly at the machine. Okay, what we call this is digital retrofit. So the idea of retrofit, maybe I'm not sure if you have heard this. Let's take an example from trains. A standard train has a lifetime of 40 to 50 years, the whole metal part, let's say, but all the parts in the train have to be refurbished about somewhere 10 to 15 years. So it's actually fairly normal for industrial companies to do refurbishment or retrofit. What we say, okay, is that this retrofit is now going digital. What we enable people and partners is to say, okay, I have my old machines, those machines are producing perfectly fine, but I want to do condition monitoring. I want to do predictive maintenance. And then we enable them with a digital retrofit to do this, okay? There's one aspect to this that, of course, is important. Keeping those machines running for a longer time is a very ecological thing. It's green, because you don't pollute, you don't have to produce new machines. This is a very ecological one. And we just won a prize here for rail responsibility, so for really being a company that is looking for the ecological parts. For example, we produce most of our electrical power by our own. But of course, being green is very nice, but to be honest, it's about money. Of course, all the companies need to earn money to survive, and that's why, of course, we want to sell something. But on the other hand, companies that have old existing legacy machines are very interested in prolonging the lifetime of the machines. So making the machine produce longer, maybe for 10 more years, and then they saved a lot of money, of course. So, of course, being green is important, but of course, probably more important at the moment for most companies is really earning money with the machines they have. Let's take an example, and actually it was a little bit surprising. I wasn't watching the agenda very carefully, and I was surprised that this plastic show is on the other halls, so it's really by accident. This is a machine from our own shop floor, which we're using at Harting. These machines are used to make insets, plastic insets in heavy-duty connectors. These machines are typically somewhere between 15 and 25 years old. And as I mentioned, when those machines were built, the internet probably didn't exist or just was in its beginning. And so we were thinking about finding ways how to connect those old machines to our IT, to make it possible that we do condition monitoring, that we have traceability, that we have quality data. And so here are some starting points. This is what people call an injection molding tool. So this is actually the big metal block, and inside of this metal block, the plastic parts are produced. And what we started with is that we said, okay, every tool that we have gets an RFID tag, okay? To be honest, RFID is a pretty old technology. It's out there for 20 years, and it has been a really hard, or the technology has really had a hard time. But it's really now coming up, because you need to talk to the things. No? It's called Internet of Things, and you need to be able to communicate with things. Where is my thing? Where is my tool? And RFID is really a good technology to find things and to identify metal objects really, really easily. Okay, so you have this RFID tag on this tool. Inside of the machine, then you have an RFID reader, and you identify your tool. Okay, so that's what we do. Again, take this little black box here, attach an antenna, have automatic identification of the tools. So now we know which tool is on the machine and where is the tool actually. And then we said, okay, knowing this tool is pretty nice, but we want to learn more about the machine and the machine health. so doing condition monitoring on these machines. And actually, we were starting with a research project. So we bought a lot of sensors on pressure, temperature, currents. So really, we spent, I don't know, something like 20K euros on sensors, just putting it onto the machine, playing around and really trying to figure out what's happening. In the end, we noticed that most sensors are not needed. It was really that we dropped almost all the sensors we bought, and what was left is that we took a simple unit to measure current. That's all that's left for condition monitoring at the moment. We threw out the temperature sensors, we threw out the pressure sensors, not needed. Because what we figured out is for getting a first impression if the machine is doing okay, this power consumption is a very, very good indicator. Of course, you need to have understanding. That was what I was mentioning in the beginning. You need to have people that understand what these values you measure do mean. So giving those figures, these numbers, a meaning. But once we figured out, okay, the current is fully sufficient, we connected those current sensors to the Mica as well, and now we correlate current data with RFID. And here the Internet of Things really comes to life. Okay? Now we know which tool is here, we know for this tool the power consumption, and now we can predict when this machine will be in trouble. At the moment we have a prediction horizon of something like 5 to 10 days, but that's not a good, because our spare parts have a delivery time of 12 weeks. So our prediction is not going far ahead enough. But at the moment it's okay. We proved that you can do condition monitoring and predictive maintenance based on very simple data, on very simple sensors. And that's important because when you talk to mid-sized companies, of course you could try to sell them a huge solution and ask them to invest, I don't know, 100,000 euros or maybe 200,000 euros, but normally they will turn down the invest because it's just way too expensive. With these solutions, you are in a range of a few thousand euros, and most customers are really willing to invest 5,000 euros, maybe 10,000 euros to have a first proof of concept and to really show that you can do IoT on old machines with this little budget. And this is really important. That's why we always show this case, because it really proves that you can start small, start with a small IoT proof of concept project, and then grow afterwards and add more functionality as you go. So this is one idea of digital retrofit. Another example, when this machine was built and developed, I was in kindergarten, and they talk a protocol which is called Euromap 15. So, to be honest, from an IT perspective, this is a really nasty protocol. So okay, it's really a byte string, and you really have to look into every byte to understand what is going on. So this machine here is really an old machine talking this protocol. The good news is that this protocol can be translated. So most machines, most plastic injection molding machines that are out there do support this protocol, and you can connect with something like our box here. So what we do is we take again the box, connect it to those old machines, and then what we did is we wrote some little piece of software that takes this Euromap 15, puts it into a, for example, MQTT broker, or OPC UA, or into Node.js or JSON or REST format. So this is a very simple idea that you say, okay, I have this old machine is doing a perfect job, probably for the next 10 years, but I have no connectivity. I cannot connect it to my SCADA, I cannot connect it to my MES, I cannot connect it to my ERP. And with such a very simple and easy solution, you can prolong your life of your machines and really get valuable data. And so that's again the idea, taking old machine, doing digital retrofit, and then on the other end, you have now a protocol that can easily be translated, easily be transferred, can be put into the cloud, could be put into any kind of database. And when you have software developers, so normal software developers as are most here on this show, which like Java, which like Python, which like Node-RED, they feel comfortable here. So they can start working, doing IoT projects on this. But if you tell them they need to work with Euromap 15, they say, okay, I'm out. That's not my business. That's too much on the machine side, too much on operational side. But with this kind of simple solution, taking some edge gateway, putting some software onto this, then you have a very easy solution of connecting old machines to these new IoT things. Just to give you an idea, this is really real, and I was talking about quality, and quality is not only about the product, but quality is also about showing that this is a real life case, and this is not made up. These are really our internal figures. So for connecting 5 old machines, we had to invest about 35,000 euros. The less of the money was for edge gateways. It was really for cabling, for getting IP addresses, so for having all these infrastructure that you need. This is what the project makes rather expensive. Although we are just talking here on a project size that most companies do find okay. But if you look at these figures here, and these are the savings within 12 months. Within 12 months, they saved almost 150,000 euros on an investment of 35,000 euros. And the interesting thing here is, what are they saving? They are saving search time. So people were really running around looking for paper in big folders. Or in this case, people were walking around taking configurations from their PC to the machine and back. So what we call sneakernet. So people were walking around with their sneakers on the shop floor. So they save a lot of money, and so you have an ROI and return on invest below 12 months. And this gives most people really, really good justification and a good argument for their owners and company owners to say, okay, I want to invest in IoT. I really want to go there, connect my old machines, because here's the ROI calculation. It's fairly simple, and I have a return on invest. Just to give you an example, and I was mentioning that I was a little bit surprised why companies like IBM, Microsoft, and Amazon were talking to Harting. And here we have now an example what you can do with the data once you have it in the cloud. You can build really beautiful, or more or less beautiful, dashboards. And the interesting part is that we can now analyze the data. And here I have one data set from our plan 2. We have worldwide about 15 plans. And cloud is really great if you can want to compare data from US to data from Europe to data from China or from India, then cloud is really perfect because you can match data very easily. And what we are doing here is really checking the dosing times, so how much plastic is injected into the tool, and here we have the power consumption. And what we are now doing together with IBM is analyze this power data here for anomalies. So is there something wrong? Is there something changing? What is the model that we can adapt and learn more about our own machines? And that's okay why we have this cooperation with IBM. But in the end, I have to say that the customer decides. I cannot tell my customer that once has machines, you now need to work with IBM. You now have to work with Microsoft. So in the end, the customer really decides what is the platform he wants to join, what platform is he working with. And just to give you an idea, Harting is here really open. We are talking to all the big IoT companies here, and our devices got now certified by Microsoft for Microsoft Azure. So it is really, really easy taking this box, talking to the old machine, and on the other side connecting it to a Microsoft Azure cloud and doing condition monitoring or some predictive analytics based on the data you're collecting. This personally, I think, is the key for Internet of Things to be successful. It's about collaboration. As I mentioned, Harting started and became very successful with connectors. So we are really, really proud. We buy tons of aluminium, we buy really a lot of gold, platinum, titanium, really bare metal. And so we were very proud on doing very much on our own, very self-contained. But when you want to make Internet of Things and IIoT successful, it's really about collaboration. And that's why we founded what we call the Mica Network. The Mica Network is a ecosystem of different partners with different qualifications. In this network, we have people that are absolute experts in automation. They know Siemens S7, they know Siemens S5, they know how to communicate with machines. On the other end, we have companies that are really experts on Microsoft Azure. they do predictive analytics, they do condition monitoring, they build really cool pieces of software based on cloud technology. And so what we figured out is that we really have to work together with different partners, technology partners, system integrators, people that really put hardware onto machines, people that understand what does it mean if I have to attach a sensor to a machine. And that's what we call Mica Network. Mica Network is the ecosystem and collection of partners that really understand how you can realize an IoT project. And that's actually from the end. So if you are here as a partner, as a system integrator, or if you have really nice technologies where you believe those could work on an edge device, or this would help to connect old machines to new IT systems, please contact us. We're still here with our booth. Drop us an email, really get in touch with us, because we are really trying to set up this Mica network around the world in different countries, and I would really be happy if you would get in touch with us. All right, thank you so much.